45 years ago, two robotic explorers launched from Earth, carrying humanity's hopes into the cosmic unknown. These twin spacecraft would travel farther than any human-made object before them, revealing worlds so alien they defied every prediction scientists had made. We'll witness a moon that spits fire into space, rings that sing like cosmic wind chimes, and storms that could swallow our entire planet whole. We'll discover oceans hidden beneath miles of ice, winds that race at impossible speeds, and the very edge of our solar system itself. Don't forget to like and subscribe as we follow these incredible machines on their journey. Prepare yourselves. We begin. Voyager 1 approached Jupiter in March 1979, its cameras focusing on a swirling red oval that astronomers had watched through telescopes for over 300 years. But nothing could have prepared scientists for what they were about to discover about this mysterious crimson mark floating in Jupiter's atmosphere. The Great Red Spot wasn't just a storm. It was a hurricane so massive that you could drop Earth inside it twice and still have room left over. As Voyager's instruments peered into this cosmic cyclone, they revealed wind speeds reaching 400 miles per hour, fast enough to circle our entire planet in just 6 hours. The storm's red color came from phosphorus compounds being churned up from deep within Jupiter's atmosphere, like cosmic blood rising to the surface. What shocked scientists most was the storm's age and stability. While hurricanes on Earth last for days or weeks before burning out, this Jovian monster had been raging for centuries without losing strength. Think of it like a spinning top that never stops. Powered by Jupiter's internal heat and the planet's rapid rotation, the storm rotates counterclockwise, completing one full rotation every 6 Earth days, moving like a giant cosmic gear in Jupiter's atmospheric machine. Voyager's close-up images revealed intricate details within the storm that no telescope could capture. Smaller storms swirled around the Great Red Spot's edges like cosmic remoras following a whale, sometimes getting absorbed into the larger system. The storm's eye measured 12,000 miles across, wide enough to swallow our moon with room to spare. Temperature readings showed the storm center was actually colder than the surrounding atmosphere, creating a high-pressure system that acts like an atmospheric mountain floating in Jupiter's sky. But the most mind-bending discovery was yet to come. Scientists realized the Great Red Spot was actually shrinking. Historical observations showed it had been twice its current size just 100 years earlier. This cosmic hurricane was slowly dying, though it would likely survive for centuries more before finally disappearing into Jupiter's turbulent atmosphere. The storm's behavior defied everything meteorologists knew about weather systems. On Earth, hurricanes weaken when they move over land or cold water. But Jupiter has no solid surface to disrupt the flow. The Great Red Spot floats in an endless ocean of gas, drawing energy from the planet's core heat 400 million miles from the warming influence of our Sun. As Voyager 1 transmitted these incredible images back to Earth, taking 18 months for the radio signals to reach mission control, scientists realized they were witnessing something unprecedented in human history. They were watching weather on an alien world, seeing storms that operated by rules completely different from anything in Earth's atmosphere. The data streaming back from Voyager revealed that Jupiter wasn't just a larger version of Earth, it was an entirely different kind of world where physics played by different rules. The Great Red Spot was just the beginning of discoveries that would revolutionize our understanding of planetary science. But compared to what Voyager would find orbiting this gas giant, even this Earth-sized storm would seem calm. Just days after Voyager 1 revealed Jupiter's secrets, it turned its cameras toward the planet's moons and discovered something that made every scientist on Earth question the laws of physics. Io, Jupiter's innermost large moon, was literally exploding before their eyes. Navigation engineer Linda Morabito was examining images for navigation purposes when she spotted something impossible, a crescent-shaped plume rising 300 miles above Io's surface. At first, mission controllers thought they were seeing a background star or a camera malfunction. But as more images arrived, the shocking truth became undeniable. Io was the most volcanically active world in our entire solar system. 8 active volcanic eruptions were visible in that first flyby, shooting sulfur and sulfur dioxide hundreds of miles into space. These weren't the gentle lava flows you might find in Hawaii. These were volcanic explosions so powerful they could launch material completely off the moon and into orbit around Jupiter. Imagine standing on a world where the ground beneath your feet constantly trembles and mountains regularly explode with the force of nuclear weapons. The volcanic plumes created umbrella-shaped clouds that spread across hundreds of miles before falling back to Io's surface like alien snow. Some eruptions reached temperatures of 3,000 degrees Fahrenheit, hot enough to melt copper instantly. The moon's surface changed so rapidly that features visible in one Voyager image had completely disappeared by the time Voyager 2 arrived 4 months later. But what was driving this incredible volcanic activity? Scientists discovered that Io was being constantly squeezed and stretched by Jupiter's immense gravity, like a cosmic stress ball in the hands of a giant. As Io orbits Jupiter, the gravitational pull from Jupiter and its neighboring moons, Europa and Ganymede, creates tidal forces that flex the moon's interior. This constant kneading generates enough heat to keep Io's interior molten, creating a world-sized volcanic furnace. The surface of Io resembled a cosmic pizza, painted in brilliant yellows, oranges, and reds from sulfur compounds. No impact craters were visible anywhere. The constant volcanic activity had erased every scar from space rocks, creating the youngest surface of any solid body in the solar system. Lava lakes bubbled and churned across the landscape, some larger than entire states on Earth. Voyager's instruments detected sulfur dioxide frost covering much of Io's surface, created when volcanic gases freeze in the moon's thin atmosphere. The volcanic plumes weren't just spectacular light shows, they were actively resurfacing the entire moon, burying the landscape under layers of fresh volcanic material every few thousand years. Think of Io as a cosmic construction site, where the entire world gets rebuilt over and over again. The discovery of Io's volcanoes proved that moons weren't just dead, airless rocks orbiting their planets. They could be dynamic, evolving worlds with their own weather systems and geological processes. This tiny moon, smaller than Earth's own satellite, was generating more volcanic activity than our entire planet. But hidden beneath the ice of Io's neighbor Europa, an even more astounding discovery was waiting to be revealed. While Io blazed with volcanic fury, its neighbor Europa appeared deceptively calm from Voyager's cameras. This ice-covered moon reflected sunlight like a cosmic mirror, showing a surface smoother than a billiard ball. But hidden beneath that pristine, frozen shell lay a secret that would change how scientists searched for life in the universe. Europa's surface revealed a puzzle of cracks and ridges that stretched across its entire frozen landscape like a shattered eggshell. These weren't random fractures. They formed organized patterns that suggested something incredible was happening beneath the ice. The moon's surface showed almost no impact craters, meaning the ice was constantly renewed and resurfaced by some hidden mechanism. Scientists studying Voyager's data realized they were looking at the frozen surface of a global ocean. Beneath Europa's ice shell, which could be anywhere from 10 to 15 miles thick, lay an ocean containing twice as much water as all of Earth's oceans combined. This subsurface sea was kept liquid by the same tidal heating that powered Io's volcanoes, but instead of creating eruptions, the energy warmed a vast underground ocean. The ice shell wasn't static. It was constantly moving and reshaping itself like frozen pack ice on Earth's polar seas. Warm water from below caused the ice to expand and crack, creating the intricate pattern of ridges and valleys that covered Europa's surface. Some areas showed where the ice had pulled apart and refroze, creating features that looked like frozen rivers running across the moon's face. Think of Europa like a cosmic egg with a shell of ice instead of calcium carbonate. Crack that shell, and you'd find not yolk, but an ocean deeper than any trench on Earth. This ocean was dark and cold, never touched by sunlight, but it was liquid water, the essential ingredient for life as we know it. Scientists began to wonder if this hidden sea might harbor living organisms in its depths. The implications were staggering. If Europa had a global ocean, it meant that habitable environments might exist throughout the outer solar system, far from the warming influence of the sun. Life might not need sunlight and moderate temperatures. It might thrive in the cold, dark depths of alien seas, drawing energy from chemical processes instead of photosynthesis. Voyager's discovery transformed Europa from just another ice-covered rock into one of the most intriguing worlds in our solar system. The smooth, youthful surface suggested the ocean below was actively connected to the surface ice, potentially allowing nutrients and chemicals to cycle between the sea and the frozen shell above. This meant Europa's ocean wasn't just a stagnant pool of water, it was a dynamic system that could support complex chemistry. The search for life beyond Earth had always focused on planets in the habitable zone, where liquid water could exist on the surface. But Europa proved that habitable worlds might be hiding in the most unexpected places, wrapped in ice and orbiting giant planets hundreds of millions of miles from the Sun. As Voyager continued its journey toward Saturn, scientists knew they had discovered something extraordinary: an entire ocean world hidden beneath a deceptively simple surface of ice. But Saturn held even more surprises, starting with rings that weren't what anyone expected. When Voyager 1 approached Saturn in November 1980, astronomers thought they understood the planet's rings pretty well. Through telescopes, Saturn appeared to have a few distinct rings, separated by dark gaps, like grooves on a cosmic record album. But as Voyager's cameras captured the ring system in unprecedented detail, scientists discovered they had been completely wrong about one of the solar system's most beautiful features. The rings weren't solid bands of material at all. They were made of countless individual chunks of ice and rock, each following its own orbit around Saturn, like a swarm of cosmic bees. Some pieces were as small as snowflakes, others as large as houses, all spinning and tumbling through space in a carefully choreographed gravitational dance that had been playing out for millions of years. What appeared as a few simple rings from Earth actually contained thousands of individual ringlets, each with its own orbital speed and characteristics. The ring system resembled a cosmic phonograph record with grooves so fine they couldn't be resolved from Earth. Some gaps between rings were caused by tiny moons, acting like cosmic shepherds, using their gravity to sweep ring particles into organized lanes. Voyager discovered that Saturn's rings were incredibly thin compared to their vast diameter. While the main ring system stretched over 170,000 miles across, nearly half the distance from Earth to the Moon, the rings were typically only about 30 feet thick. Imagine a sheet of paper scaled up to the size of a football field, and you'd get an idea of how remarkably flat Saturn's rings really were. The ice particles in the rings sparkled like diamonds in sunlight, creating one of the most spectacular sights in the solar system. These weren't dirty chunks of rock. They were mostly pure water ice, probably formed when comets or small moons were torn apart by Saturn's powerful gravity. The largest pieces tumbled slowly as they orbited, creating a gentle cosmic snowstorm that had been falling for eons. But the biggest surprise came when Voyager discovered structures within the rings that seemed to defy physics. Some ringlets appeared braided together like cosmic rope, while others showed dark spokes that rotated with the rings despite having no apparent physical cause. These spokes appeared and disappeared, like ghostly shadows moving across the ring plane, created by electromagnetic forces that charged tiny dust particles and lifted them above the main ring structure. Saturn's gravity wasn't the only force shaping the rings. The planet's magnetic field interacted with charged particles, creating waves and disturbances that propagated through the ring system like ripples on a pond. Small moons embedded within the rings carved gaps and maintained sharp edges through gravitational shepherding, while resonances with larger moons created spiral density waves that looked like frozen sonic booms. The ring system was incredibly dynamic, constantly changing as particles collided, stuck together, and broke apart again. What looked like a static, unchanging structure from Earth was actually a bustling ecosystem of ice and rock in constant motion. Scientists realized they were watching the birth and death of ring particles in real time, witnessing processes that had been shaping planetary ring systems for billions of years. These discoveries revolutionized understanding of how ring systems form and evolve, providing insights that would prove crucial for understanding similar structures around other planets throughout the universe. But hidden among Saturn's many moons, an even stranger world was waiting to reveal secrets that would rewrite the textbooks on planetary atmospheres. Among Saturn's 62 known moons, one stood out as completely unique even before Voyager arrived. Titan, Saturn's largest moon, was shrouded in a thick orange atmosphere that completely hid its surface from view. But when Voyager 1 flew past this mysterious world in November 1980, it discovered something that made scientists question everything they thought they knew about planetary atmospheres. Titan's atmosphere was thicker than Earth's, creating a surface pressure 1.5 times greater than what we experience at sea level. This made Titan the only moon in our solar system with a substantial atmosphere thick enough for a human to walk around without a pressure suit, though you'd still need oxygen and protection from the frigid cold. The atmosphere extended hundreds of miles above the surface, creating a hazy orange glow that gave the moon an almost Earth-like appearance from space. But this wasn't an atmosphere made of the familiar nitrogen and oxygen that we breathe. Titan's air was 95% nitrogen, with traces of methane, creating a cocktail of gases that produced complex organic chemistry in the upper atmosphere. Sunlight broke apart methane molecules, causing them to recombine into larger organic compounds that fell to the surface like cosmic snow, painting the landscape in orange and brown hydrocarbons. The thick atmosphere created weather patterns that mirrored Earth's in startling ways. Clouds formed and dissipated, winds circulated around the globe, and seasonal changes occurred as Titan orbited Saturn. But instead of water vapor forming clouds, methane evaporated from Titan's surface and condensed in the cold upper atmosphere, creating weather systems based on liquid methane instead of water. Scientists realized they were looking at a world where methane played the same role that water plays on Earth. Methane rain fell from orange clouds, carved river channels across the landscape, and collected in vast lakes near Titan's polar regions. This created a complete hydrological cycle based on hydrocarbons instead of water, the only other world in our solar system known to have liquid flowing on its surface. The atmospheric pressure and composition meant that if you could somehow survive the cold, you could actually fly on Titan using wings strapped to your arms. The thick atmosphere and low gravity, just 14% of Earth's, would make human-powered flight not just possible, but relatively easy. Imagine soaring through orange skies above methane lakes and hydrocarbon dunes. Voyager's infrared instruments detected temperature variations across Titan's surface that suggested diverse geographical features hidden beneath the atmospheric haze. The equatorial regions appeared warmer and likely contained vast dune fields made of organic sand particles, while the polar regions showed the cold signatures of liquid methane and ethane lakes. The organic chemistry happening in Titan's atmosphere created a natural laboratory for studying how complex carbon compounds form and evolve. The moon was essentially a giant chemistry experiment, producing organic molecules that fell to the surface and accumulated over millions of years. Scientists began to wonder if this organic-rich environment might provide clues about how life began on early Earth. Titan's thick atmosphere also protected the surface from space radiation and meteorite impacts, creating a stable environment where complex chemistry could proceed undisturbed for geological timescales. This made Titan a time capsule, preserving conditions that might have existed on early Earth before life began altering our planet's atmosphere. But while Titan hid its secrets beneath atmospheric haze, another of Saturn's moons was about to reveal one of the most spectacular discoveries in the solar system. As Voyager 2 approached Saturn in August 1981, mission planners focused most attention on the planet's magnificent rings and its mysterious moon Titan. But a small, icy moon named Enceladus was about to steal the show with a discovery that would revolutionize how scientists thought about life in the outer solar system. Enceladus appeared to be just another boring ice ball, barely 300 miles across and covered in pristine white ice that reflected almost all the sunlight hitting its surface. This tiny moon was so bright it practically glowed in Voyager's images, looking like a cosmic snowball floating in the darkness. But hidden beneath that innocent exterior was one of the most geologically active worlds in the entire solar system. Voyager's cameras revealed that Enceladus had virtually no impact craters on its surface, a clear sign that something was constantly erasing the scars left by space rocks over billions of years. The southern hemisphere showed a complex landscape of ridges, valleys, and smooth plains that looked remarkably young compared to other icy moons. Scientists realized they were looking at a world where geological processes were actively reshaping the surface. But the most incredible discovery came when Voyager detected something unprecedented near Enceladus's south pole. Massive plumes of water vapor and ice particles were erupting from the surface, shooting hundreds of miles into space like cosmic geysers. These weren't gentle puffs of gas. They were powerful eruptions launching material at speeds of over 800 miles per hour, fast enough to escape the moon's weak gravity entirely. The geysers emerged from a series of parallel cracks near the South Pole that scientists nicknamed tiger stripes because of their distinctive appearance. These fractures were warmer than the surrounding ice, suggesting that liquid water existed just beneath the surface. The erupting material contained not just water ice, but also organic compounds and minerals that could only come from a subsurface ocean. Think of Enceladus like a cosmic pressure cooker with a leaky valve. Tidal heating from Saturn's gravity keeps a global ocean liquid beneath the ice shell, and this water occasionally finds its way to the surface through cracks and fissures. When the pressurized water reaches the vacuum of space, it instantly vaporizes and freezes, creating spectacular ice fountains that feed Saturn's outermost ring. The discovery of liquid water erupting from Enceladus meant that this tiny moon harbored another subsurface ocean similar to Europa, but with direct access to the surface through the polar geysers. Scientists realized they could potentially sample this alien ocean without ever landing on the moon. They just needed to fly a spacecraft through the erupting plumes and analyze the particles. Temperature measurements showed that the tiger stripe region was significantly warmer than it should be based on sunlight alone. Something inside Enceladus was generating heat, keeping the water liquid despite the moon's vast distance from the sun. The tidal forces from Saturn were kneading the moon's interior like cosmic hands working bread dough, generating enough friction to melt ice into a global ocean. The geysers weren't constant. They varied in intensity and sometimes shut off completely before resuming their spectacular displays. This suggested that the underground plumbing system was complex, with chambers and channels that could become blocked or cleared by geological processes. Enceladus was essentially a cosmic version of Yellowstone's geysers, but powered by tidal forces instead of volcanic heat. As Voyager departed the Saturn system, scientists knew they had discovered one of the most promising places to search for life beyond Earth, a small moon with liquid water erupting directly into space. But the next stop on Voyager's grand tour would reveal a planet so strange it defied every expectation. 5 years after leaving Saturn, Voyager 2 approached a world unlike anything else in our solar system. Uranus hung in space like a cosmic bowling ball, rotating on its side with its poles pointing toward and away from the sun instead of spinning upright like every other planet. This bizarre orientation created the strangest seasons imaginable. Each pole experienced 42 years of continuous sunlight, followed by 42 years of complete darkness. When Voyager 2 flew past Uranus in January 1986, it became the first and only spacecraft to visit this distant ice giant. From Earth, Uranus appeared as little more than a bluish-green dot through even the most powerful telescopes. But Voyager's close-up images revealed a world that seemed almost featureless at first glance. A smooth, blue-green sphere with barely any visible clouds or atmospheric disturbances. The planet's unusual color came from methane in its atmosphere, which absorbed red light and reflected blue and green wavelengths back into space. Unlike Jupiter and Saturn with their swirling bands and dramatic storms, Uranus appeared eerily calm. The lack of atmospheric features puzzled scientists until they realized they were viewing the planet during its most inactive season. Voyager arrived when one of Uranus's poles was pointing almost directly at the Sun. But beneath that bland exterior lurked one of the most unusual magnetic fields in the solar system. Instead of aligning with the planet's rotational axis like Earth's magnetic field, Uranus's magnetic field was tilted 59 degrees off-center and didn't even pass through the planet's core. The magnetic field seemed to originate from somewhere deep within the planet's mantle, creating a lopsided magnetic environment that defied all previous models of planetary magnetism. The discovery of Uranus's tilted magnetic field suggested that something catastrophic had happened to this planet in the distant past. Scientists theorized that a massive collision with an Earth-sized object had knocked Uranus onto its side, scrambling its internal structure and creating the bizarre magnetic field configuration. This cosmic collision would have been one of the most violent events in the solar system's history, completely restructuring an entire planet. Voyager also discovered that Uranus had rings, though they were completely different from Saturn's brilliant ice rings. Uranus's rings were dark as charcoal, made of particles that absorbed almost all the light hitting them. These narrow, rope-like rings were held in place by small shepherd moons that Voyager discovered orbiting between the ring boundaries. The ring particles were probably organic compounds that had been darkened by radiation over millions of years. The planet's moons proved to be just as unusual as Uranus itself. Voyager discovered 10 new moons in addition to the 5 already known from Earth-based observations. These moons were a mixture of ice and rock, but they showed signs of geological activity that seemed impossible for such cold, distant worlds. Some moons displayed evidence of past volcanism or tectonic activity, suggesting that Uranus's gravitational influence could generate enough heat to drive geological processes. The most intriguing moon was Miranda, which looked like it had been smashed apart and reassembled incorrectly. Its surface showed a bizarre patchwork of different terrains: smooth plains next to heavily cratered regions, enormous cliffs taller than the Grand Canyon, and grooved terrain that looked like cosmic corduroy. Miranda appeared to be a geological nightmare, as if several different worlds had been cut up and glued together randomly. Uranus's extreme axial tilt created the most unusual seasons in the solar system. During summer at each pole, the sun never set for decades, while the opposite hemisphere remained in complete darkness. This created temperature differences and atmospheric dynamics, unlike anything found on other planets, though the effects were subtle due to Uranus's vast distance from the Sun. As Voyager 2 departed this strange sideways world, it carried data that would puzzle scientists for decades, heading toward its final planetary encounter with an even more mysterious ice giant. 3.5 years after leaving Uranus, Voyager 2 approached the solar system's most distant giant planet. Neptune lurked in the cosmic darkness, receiving only 1,000th the sunlight that Earth enjoys. Yet this seemingly frozen world was about to reveal the most dynamic and violent atmosphere in the entire solar system. From a distance, Neptune appeared as a brilliant blue marble, decorated with wispy white clouds that raced across its surface at impossible speeds. Unlike the bland, featureless Uranus, Neptune blazed with atmospheric activity despite receiving so little energy from the distant sun. The planet's deep blue color came from methane in its atmosphere, but Neptune's blue was far more vibrant and intense than Uranus's pale green-blue tint. Voyager's instruments immediately detected something extraordinary. Winds on Neptune were racing at over 1,500 miles per hour, faster than the speed of sound on Earth. These weren't just gentle breezes, they were supersonic hurricanes that could circle the entire planet in less than 18 hours. The fastest winds in the solar system were blowing on the coldest planet, a paradox that baffled atmospheric scientists. The most prominent feature was a massive storm system that scientists nicknamed the Great Dark Spot, similar to Jupiter's Great Red Spot, but proportionally even larger compared to the planet's size. This cosmic hurricane was big enough to swallow Earth whole, with winds spinning counterclockwise at tremendous speeds around a dark central eye. Unlike Jupiter's ancient storm, Neptune's great dark spot appeared to be a relatively young and dynamic feature. But how could such violent weather exist on a world so far from the sun's warmth? Scientists discovered that Neptune was radiating more than twice as much energy into space as it received from sunlight. The planet was essentially a cosmic furnace, generating its own heat from gravitational compression and leftover energy from its formation 4.5 billion years ago. This internal heat source drove the incredibly active atmosphere despite the planet's frigid distance from the sun. The white clouds streaking across Neptune's blue surface were made of methane ice crystals that formed high in the atmosphere where temperatures dropped to -360 degrees Fahrenheit. These clouds moved at different speeds than the underlying atmospheric layers, creating a complex multi-level weather system with jet streams racing at different altitudes. Some clouds changed dramatically during Voyager's brief encounter, appearing and disappearing within hours. Neptune's magnetic field proved to be just as strange as Uranus's, tilted 47 degrees from the planet's rotational axis and offset from the center by about half the planet's radius. This similarity to Uranus suggested that extreme magnetic field orientations might be normal for ice giant planets, challenging scientists' understanding of how planetary magnetic fields form and evolve. The planet's largest moon, Triton, immediately caught scientists' attention because it was orbiting backwards, the only large moon in the solar system with a retrograde orbit. This suggested that Triton was actually a captured object, probably a dwarf planet similar to Pluto that had been gravitationally captured by Neptune eons ago. The capture process would have been violent, destroying any other large moons that might have originally orbited Neptune. Triton itself proved to be one of the most geologically active worlds in the outer solar system, despite its incredible distance from the Sun. Voyager detected nitrogen geysers erupting from Triton's surface, shooting dark material up to 5 miles high into the thin atmosphere. These eruptions were probably driven by solar heating of nitrogen ice beneath Triton's surface, creating pressure that eventually exploded through weak spots in the crust. The discovery of active geology on Triton at such a vast distance from the Sun revolutionized scientists' thinking about where geological activity could exist in the solar system. If tiny amounts of solar energy could drive eruptions on Triton, then geological processes might be active throughout the outer solar system, even on worlds that seemed completely frozen and dead. As Voyager 2 completed its encounter with Neptune and Triton, it had finished its grand tour of the outer planets, but its most remarkable discoveries still lay ahead, at the very edge of our solar system. 35 years after launching from Earth, Voyager 1 was racing through space far beyond the orbit of Pluto, carrying instruments that still functioned perfectly despite decades of cosmic radiation and extreme cold. Mission scientists expected the spacecraft to eventually reach a boundary called the heliopause, the edge of our solar system, where the sun's influence finally gives way to interstellar space. But nobody knew exactly where this boundary lay or what it would look like when Voyager found it. The solar system isn't just planets and moons floating in empty space. It's filled with a constant stream of charged particles flowing outward from the sun called the solar wind. This invisible river of plasma creates a massive bubble around our entire solar system, pushing against the thin gas that exists between stars. The heliopause marks the boundary where the solar wind finally meets its match and can push no further into the galaxy. As Voyager 1 traveled beyond 100 astronomical units from the sun, more than 100 times Earth's distance from our star, its instruments began detecting strange changes in the space environment around the sun. The density of cosmic rays from deep space was increasing, while the intensity of particles from the sun was decreasing. The spacecraft was approaching a cosmic border that had never been crossed by any human-made object. In August 2012, Voyager 1's instruments detected a sudden drop in the number of solar particles reaching the spacecraft, followed by a dramatic increase in cosmic rays from interstellar space. The transition happened within a few days. One moment, Voyager was still inside our solar system. The next, it had crossed into the space between stars. After 35 years of travel, humanity had finally touched the edge of home. The heliopause wasn't a sharp wall like scientists had expected. It was more like a boundary layer where solar and interstellar influences gradually blended together. The magnetic field strength remained relatively constant across the boundary, suggesting that interstellar space was more organized and structured than anyone had predicted. Instead of crossing into cosmic chaos, Voyager found that the space between stars had its own magnetic highways and particle flows. But the most surprising discovery was how different interstellar space felt compared to the solar environment Voyager had known all its life. The background noise of plasma waves changed dramatically, like stepping from a busy highway into a quiet forest. The cosmic ray environment was more intense, but also more steady, without the fluctuations caused by solar storms and magnetic field changes from our sun. Scientists realized they were receiving the first direct measurements of the local interstellar medium, the thin soup of gas and dust that fills the space between stars in our galaxy. This material was the leftover debris from ancient supernovas and stellar winds, seasoned with heavy elements forged in the nuclear furnaces of long-dead stars. Voyager was sampling the very substance from which new stars and planets would eventually form. The crossing also revealed that our solar system was moving through interstellar space at about 52,000 miles per hour relative to the nearby stars. This motion created a bow shock ahead of our solar system, like the wake of a boat moving through water. Voyager's measurements helped scientists map this cosmic bow wave and understand how our solar system interacted with the galactic environment around it. Temperature measurements showed that interstellar space was actually warmer than the outer regions of our solar system, heated by cosmic rays and starlight from the Milky Way galaxy. The interstellar medium had a temperature of about 80,000 degrees Fahrenheit, though the gas was so thin that a thermometer would read near absolute zero due to the lack of particles to transfer heat. As Voyager 1 continued deeper into interstellar space, it was writing the first chapter of humanity's exploration beyond our solar system, carrying its golden record message into the cosmic ocean between stars. But 37 years after launch, Voyager 2 was about to make its own historic crossing into this alien realm. 6 years after Voyager 1 crossed the heliopause, its twin spacecraft was approaching the same historic boundary from a different direction. Voyager 2 had taken a different path through the outer solar system, using gravitational assists to visit all 4 giant planets before heading toward its own rendezvous with interstellar space. When it finally crossed the boundary in November 2018, the data it sent back revealed that the edge of our solar system was far more complex than anyone had imagined. Unlike Voyager 1's relatively smooth transition, Voyager 2 experienced a much more turbulent crossing. The spacecraft detected multiple boundary crossings over several months, as if the heliopause was rippling like a flag in cosmic wind. Sometimes Voyager 2 was in interstellar space, other times it was back in the solar wind, and occasionally it seemed to be in a strange middle ground where neither environment dominated. The 2 spacecraft revealed that the heliosphere, our solar system's protective bubble, wasn't a perfect sphere at all. It was lopsided and constantly changing shape as it plowed through the interstellar medium. The sun's magnetic field and solar wind created a complex 3-dimensional structure that varied depending on solar activity and the changing galactic environment our solar system encountered. Voyager 2's working plasma instrument provided the first direct measurements of interstellar plasma density and temperature. The data showed that interstellar space was filled with a thin but measurable gas that was significantly denser than the solar wind that had surrounded both spacecraft for decades. This interstellar material was compressed and heated by our solar system's passage through it, creating a bow shock wave ahead of our cosmic motion. Both Voyagers detected something unexpected. The magnetic field in local interstellar space was much stronger and more organized than theoretical models had predicted. Instead of the weak, chaotic magnetic environment scientists expected, the spacecraft found well-defined magnetic highways that channeled cosmic rays and charged particles across vast distances. These magnetic field lines were probably connected to nearby star-forming regions and supernova remnants. The cosmic ray environment in interstellar space proved to be dramatically different from anything measured inside our solar system. High-energy particles from distant galactic sources bombarded both spacecraft constantly, creating a radiation environment that would be lethal to unprotected humans. These cosmic rays carried information about stellar explosions, neutron stars, and black holes throughout our local region of the galaxy. Temperature measurements revealed the strange physics of interstellar space. While the plasma temperature was tens of thousands of degrees, the actual gas density was so low that a human would instantly freeze to death. The few atoms present were moving at incredible speeds due to their high temperature, but there were so few of them that they couldn't transfer meaningful amounts of heat to solid objects. Scientists realized that both Voyagers were now sampling the raw material from which stars and planets form throughout the galaxy. The interstellar medium contained hydrogen and helium left over from the Big Bang, mixed with heavier elements forged in stellar cores and dispersed by supernova explosions. This cosmic recycling process had been enriching the galaxy with heavy elements for billions of years. The data streaming back from both spacecraft was rewriting textbooks about the structure of our solar system and its place in the galaxy. The heliosphere wasn't just a static bubble, it was a dynamic structure that breathed and flexed as our solar system encountered different regions of interstellar space during its orbit around the galactic center. Both Voyagers were now ambassadors from Earth, sailing through the cosmic ocean between stars, carrying humanity's first messages to any alien civilizations they might encounter. Their nuclear power sources would keep their transmitters running for perhaps another decade, continuing to send back data about the unexplored frontier beyond our solar system. As these two small spacecraft disappeared into the darkness between stars, they marked the beginning of humanity's transformation from a single-planet species to explorers of the galaxy itself, having shown us wonders that expanded our understanding of the cosmos and our place within it. As Voyager 1 approached Jupiter, mission controllers knew they were sending their precious spacecraft into one of the most dangerous environments in the solar system. Jupiter's immense magnetic field, 20,000 times stronger than Earth's, trapped high-energy particles in invisible belts that surrounded the planet like cosmic death rays. These radiation belts could fry electronic circuits in minutes and would kill any unprotected human almost instantly. The radiation environment around Jupiter was so intense that it made the Van Allen belts surrounding Earth look like gentle summer rain compared to a Category 5 hurricane. Charged particles spiraled back and forth along Jupiter's magnetic field lines at nearly the speed of light, creating a particle accelerator that dwarfed anything humans had built on Earth. The radiation was intense enough to damage Voyager's cameras and instruments, even through their protective shielding. Scientists discovered that Jupiter's radiation belts were fed by material from Io's volcanic eruptions. The sulfur and oxygen blasted into space by Io's volcanoes became ionized by Jupiter's radiation, creating a donut-shaped cloud of charged particles that orbited the planet. These particles were then accelerated to incredible energies by Jupiter's rotating magnetic field, turning peaceful volcanic gases into cosmic bullets, moving at relativistic speeds. The radiation environment varied dramatically depending on distance from Jupiter and position relative to the planet's magnetic field. Near Io's orbit, the radiation was so intense that it would deliver a lethal dose to a human in less than 1 second. Even at Europa's distance, the radiation levels were thousands of times higher than anything experienced on Earth, enough to kill in minutes despite being much farther from Jupiter's surface. Voyager's instruments detected radio emissions from Jupiter's radiation belts that could be heard on Earth with simple shortwave radios. These emissions were created when high-energy electrons spiraled through Jupiter's magnetic field, generating radio waves that propagated across the solar system. Amateur radio operators had been detecting these Jovian radio bursts for decades without understanding their origin. The spacecraft's passage through Jupiter's radiation environment provided the first direct measurements of how planetary magnetic fields trap and accelerate charged particles. Scientists realized they were studying a natural particle accelerator that had been operating for billions of years, creating conditions more extreme than anything that could be reproduced in terrestrial laboratories. Temperature measurements showed that Jupiter's radiation belts were incredibly hot, not in the traditional sense, but in terms of particle energy. Individual electrons and protons in the belts had temperatures equivalent to millions of degrees, though the low particle density meant that solid objects wouldn't be heated by conduction. Instead, the danger came from radiation damage as high-energy particles smashed through electronic components. The radiation belts also affected Jupiter's moons in different ways. Io, orbiting deep within the most intense radiation, had its atmosphere constantly stripped away and replenished by volcanic activity. Europa's ice surface was bombarded by radiation that broke water molecules apart, creating a thin oxygen atmosphere through radiolysis. Ganymede's magnetic field provided some protection, while Callisto orbited far enough out to avoid the worst radiation. Voyager's successful passage through Jupiter's radiation environment proved that carefully shielded spacecraft could survive even the most hostile radiation environments in the solar system. But the data also revealed just how deadly these invisible particle storms could be for any future human explorers. As Voyager departed Jupiter's lethal radiation zone, it carried crucial data about one of the most extreme environments in our solar system, heading towards Saturn, where new atmospheric mysteries awaited discovery. When Voyager 1 first glimpsed Saturn's North Pole in 1980, mission scientists thought they were seeing an optical illusion or camera malfunction. The images showed what appeared to be a perfectly geometric hexagon surrounding Saturn's northern polar region, a six-sided storm system that looked more like artificial architecture than natural weather. No planet had ever been observed with geometric weather patterns, and the discovery challenged everything meteorologists thought they knew about atmospheric dynamics. The hexagon was enormous, spanning nearly 15,000 miles from side to side, wide enough to fit two Earths inside with room to spare. Each side of this cosmic geometry was longer than the diameter of Earth, making it one of the largest coherent structures ever observed in any planetary atmosphere. The hexagon appeared to be a jet stream of sorts, with winds racing around its perimeter at over 200 miles per hour in a perfectly straight-sided pattern. But how could nature create such a geometrically perfect structure? Storms on Earth and other planets typically form circular or oval patterns because rotating fluids naturally organize into curved flows. The idea of a hexagonal hurricane seemed to violate the basic laws of fluid dynamics, yet there it was, spinning majestically around Saturn's North Pole like a cosmic snowflake drawn by an impossibly precise hand. Scientists realized they were witnessing something that had probably been stable for decades or even centuries. The hexagon wasn't a temporary weather pattern, it was a permanent feature of Saturn's atmosphere, as persistent as the Great Red Spot on Jupiter, but far more geometrically precise. The structure showed no signs of breaking up or changing shape, maintaining its perfect six-sided form despite the chaotic turbulence of the surrounding atmosphere. Laboratory experiments later revealed how such geometric patterns could form in rotating fluids. When a circular jet stream is disturbed by specific types of waves, it can lock into polygon shapes with 3, 4, 5, 6, or even more sides depending on the wave characteristics. Saturn's hexagon represented a natural example of this phenomenon scaled up to planetary proportions, creating geometric perfection through the complex mathematics of fluid dynamics. The center of the hexagon contained a massive hurricane with a clearly defined eye, similar to terrestrial hurricanes but much larger and more persistent. This central storm was about the size of Earth and appeared to be the anchor point around which the hexagonal jet stream organized itself. Winds in the eye wall reached speeds of over 300 miles per hour, making it one of the most intense storms in the solar system. Temperature measurements showed that the hexagon was actually a cold feature compared to the surrounding atmosphere. The geometric jet stream acted like a barrier, preventing warm air from the equatorial regions from mixing with the polar atmosphere. This temperature difference helped maintain the sharp boundaries that gave the hexagon its precise edges, creating a self-reinforcing system that could persist for geological time periods. The discovery of Saturn's hexagon proved that planetary atmospheres could create structures of stunning mathematical beauty and precision. The storm represented a perfect marriage of chaos and order, where the random turbulence of atmospheric convection organized itself into one of the most geometrically perfect natural structures ever observed in the solar system. Seasonal changes as Saturn orbited the Sun caused subtle variations in the hexagon's appearance and intensity, but the basic six-sided structure remained constant. Scientists realized they were observing a fundamental property of how rotating atmospheric systems organize themselves under certain conditions, providing insights into weather patterns throughout the universe. But while Saturn's hexagon represented atmospheric order and precision, the magnetic environments of the outer planets revealed chaos and unpredictability that would challenge scientists' understanding of planetary physics. When Voyager 2 flew past Uranus in 1986, scientists expected to find a magnetic field similar to Earth's, roughly aligned with the planet's rotation axis and centered on the planetary core. Instead, they discovered one of the most bizarre and twisted magnetic environments in the entire solar system, a cosmic compass that seemed to have been shattered and reassembled incorrectly by some ancient catastrophe. Uranus's magnetic field was tilted 59 degrees away from the planet's rotation axis, as if someone had grabbed a bar magnet and twisted it nearly sideways before shoving it back inside the planet. Even more strangely, the magnetic field didn't even pass through Uranus's center. It was offset by about 1/3 of the planet's radius, creating a lopsided magnetic environment unlike anything found around any other planet. The magnetic field strength varied wildly depending on location around Uranus. In some regions, it was stronger than Earth's magnetic field, while in other areas, it was barely detectable. This created a chaotic magnetosphere where charged particles followed twisted, unpredictable paths, instead of the organized radiation belts found around other planets. Voyager's instruments detected particles spiraling in corkscrew patterns that defied conventional models of planetary magnetism. Scientists struggled to explain how such a distorted magnetic field could exist. On Earth, the magnetic field is generated by electric currents in the molten iron core, creating a relatively stable dipole field that resembles a giant bar magnet. But Uranus's magnetic field seemed to originate from multiple sources scattered throughout the planet's interior, as if several smaller magnetic generators were operating independently inside the world. The discovery suggested that Uranus had suffered some kind of catastrophic event in its past that completely scrambled its internal structure. The same collision that knocked the planet onto its side might have disrupted the normal convection patterns in its interior, creating the chaotic magnetic field configuration that Voyager observed. This cosmic accident had left Uranus with a magnetic environment that was fundamentally different from every other planet. The twisted magnetic field created equally twisted auroras around Uranus's poles. Instead of the elegant curtains of light that dance around Earth's polar regions, Uranus's auroras appeared as chaotic knots and spirals that moved unpredictably across the planet's atmosphere. These alien light shows were powered by the same charged particles that create Earth's auroras, but the distorted magnetic field channeled them in completely different patterns. Temperature measurements revealed that Uranus's magnetosphere was surprisingly cold compared to other planets. The chaotic magnetic field couldn't efficiently trap and heat-charged particles like the organized magnetic environments around Jupiter and Saturn. This created a magnetosphere that was not only twisted, but also relatively inactive compared to the dynamic particle environments around other giant planets. The magnetic field measurements also revealed something unexpected about Uranus's interior structure. The planet appeared to have distinct layers with different electrical properties, suggesting that Uranus was more like a partially mixed cocktail than the well-stirred fluid interiors found in Jupiter and Saturn. Water, methane, and ammonia ices might exist in separate layers deep inside the planet, each contributing differently to the overall magnetic field. Voyager's magnetometer continued detecting strange magnetic signatures, even as the spacecraft departed Uranus. The planet's magnetic tail, the region where the magnetic field stretches away from the Sun, was twisted into a helical pattern that rotated like a cosmic corkscrew as Uranus spun on its tilted axis. This created a magnetic signature unlike anything else in the solar system, The bizarre magnetic environment around Uranus demonstrated that planetary magnetic fields could be far more complex and chaotic than scientists had previously imagined, providing clues about the violent processes that shaped the outer planets during the solar system's formation. But the magnetic mysteries discovered at Uranus were just preparation for even stranger magnetic phenomena that awaited at Neptune. When Voyager 2 captured images of Neptune's Great Dark Spot in 1989, scientists assumed they were documenting a permanent feature similar to Jupiter's ancient Great Red Spot. This massive storm system was proportionally larger than Jupiter's famous hurricane, big enough to contain the entire Earth within its swirling winds. But when the Hubble Space Telescope turned its gaze toward Neptune just 5 years later, the Great Dark Spot had completely vanished without a trace. The disappearance of such a massive storm system baffled atmospheric scientists. On Jupiter, the Great Red Spot had been raging for at least 3 centuries and showed no signs of weakening. How could Neptune's equally impressive storm simply evaporate in less than a decade? The answer revealed fundamental differences between the atmospheric dynamics of gas giant planets and ice giants like Neptune. Neptune's atmosphere was far more dynamic and turbulent than Jupiter's, driven by the planet's internal heat source rather than solar energy. The rapid atmospheric changes meant that storm systems could form and dissipate much more quickly than on Jupiter, where the thicker atmosphere and lower energy density created more stable weather patterns. Neptune was essentially a cosmic weather laboratory where atmospheric features appeared and disappeared on human timescales. The Great Dark Spot wasn't just any storm, it was an anticyclonic system with winds rotating in the opposite direction from the planet's rotation. These high-pressure systems are relatively rare in planetary atmospheres and require specific conditions to form and maintain themselves. When those conditions changed, the storm couldn't sustain itself and gradually dissolved into the surrounding atmospheric chaos. Hubble's continued observations revealed that Neptune regularly produces and destroys large dark spots in its atmosphere. New storm systems would appear in different locations, grow to enormous sizes, persist for months or years, then fade away as atmospheric conditions shifted. Neptune's atmosphere was like a cosmic storm factory, constantly creating and recycling massive weather systems. The vanishing act of the Great Dark Spot demonstrated that Neptune's atmosphere was far more active than its distance from the Sun would suggest. Despite receiving only 1,000th the solar energy that Earth enjoys, Neptune generated the most dynamic weather in the solar system through its powerful internal heat source. The planet was radiating 2.5 times more energy than it received from the Sun, creating atmospheric instability that drove rapid weather changes. Scientists realized that the ice giant planets, Uranus and Neptune, operated by completely different rules than the gas giants, Jupiter and Saturn. While Jupiter and Saturn had relatively stable atmospheric features that persisted for centuries, the ice giants showed rapid atmospheric evolution that could completely reshape their appearance within decades. This made them much more challenging to study and understand. The discovery that major atmospheric features could appear and disappear so quickly revolutionized how scientists thought about planetary weather systems. It suggested that many planets might have highly variable atmospheres where dramatic changes occur on human timescales rather than geological time periods. This variability made the ice giants some of the most dynamic worlds in the solar system. Temperature and wind measurements showed that Neptune's atmospheric activity was driven by powerful convection currents that transported heat from the planet's interior to its upper atmosphere. These convection cells created and destroyed weather systems as they organized and reorganized themselves, like cosmic thunderstorms that could spawn hurricane-sized vortices. The rapid atmospheric evolution also suggested that Neptune's weather might be influenced by seasonal changes as the planet orbited the Sun. With each season lasting over 40 Earth years, atmospheric patterns might shift on decadal timescales as different hemispheres experienced changes in solar heating. As Neptune's Great Dark Spot faded into atmospheric history, scientists were reminded that the outer planets were not static, unchanging worlds, but dynamic systems capable of dramatic transformation over surprisingly short time periods. But while Neptune's storms came and went, both Voyager spacecraft carried something designed to last forever, humanity's message to the stars. Attached to each Voyager spacecraft was perhaps the most ambitious message ever created, a golden phonograph record containing sounds, images, and greetings from Earth designed to communicate with any alien civilization that might find the spacecraft in the distant future. This cosmic time capsule represented humanity's first attempt to introduce ourselves to intelligence beyond our solar system. The golden record contained 115 images depicting life on Earth, from scientific diagrams showing human anatomy and DNA structure to photographs of people from different cultures around the world. The record included sounds of Earth, everything from whale songs and bird calls to a crying baby and the footsteps of someone walking. Musical selections ranged from Bach and Beethoven to traditional folk songs from different cultures, creating a sonic portrait of human civilization. Creating this interstellar message required solving unprecedented communication challenges. How do you explain human concepts to minds that might think in completely alien ways? The record began with basic mathematical and physical concepts that any technological civilization would understand, using these universal principles as a foundation for more complex information about Earth and humanity. The cover of the golden record contained instructions for playing it, engraved as diagrams that showed how to construct a stylus and determine the correct playing speed. These instructions used the spin transition of hydrogen atoms as a universal time reference, since any civilization advanced enough to intercept Voyager would understand atomic physics. The diagrams also showed the position of our Sun relative to 14 nearby pulsars, creating a cosmic address that aliens could use to locate Earth. Spoken greetings in 55 human languages were included on the record, from ancient Sumerian to modern Mandarin Chinese. Each greeting was a simple message of peace and goodwill, acknowledging that any beings capable of finding and playing the record would possess technology far beyond our own. The variety of languages demonstrated the diversity of human culture, while emphasizing our common desire for communication and understanding. The record also contained an hour and a half of music that told the story of human creativity and emotion. Classical compositions demonstrated our mathematical understanding of harmony and rhythm, while folk songs revealed the cultural diversity that flourished across our planet. The musical selections were chosen to represent the full range of human expression, from joy and celebration to melancholy and spiritual reflection. Scientific information on the record included diagrams of human reproduction, the structure of DNA, and mathematical definitions of basic physical constants. These images attempted to explain what humans are as biological entities and how we understand the universe around us. The record even included a diagram showing the trajectory of the Voyager spacecraft themselves, indicating where they came from in our solar system. But perhaps the most poignant aspect of the golden record was its representation of Earth as our home. Images showed our planet from space, revealing the blue marble hanging in cosmic darkness that represents the only known haven for life in the universe. Other images depicted Earth's environments, oceans, forests, deserts, and cities, showing the incredible diversity of landscapes that exist on our world. The golden record was designed to last for billions of years in the vacuum of space, outliving human civilization and possibly even our sun. The gold-plated copper disc was protected by an aluminum cover that would shield it from cosmic radiation and micrometeorite impacts during its journey through interstellar space. If aliens ever found it, they would be discovering a message from a species that might no longer exist. As both Voyager spacecraft carried their golden records into the darkness between stars, they represented humanity's hope that we are not alone in the universe and our desire to reach across the cosmic gulf to touch other minds that might be wondering about their place in the cosmos. But closer to home, Voyager's discoveries about Jupiter's moons were revealing magnetic mysteries that challenged our understanding of how small worlds could generate their own protective magnetic shields. Among Jupiter's 4 largest moons, Ganymede stood out as an anomaly from the moment Voyager 1 first detected its unusual properties. This ice-covered world, larger than the planet Mercury, possessed something that no other moon in the solar system could claim: its own internally generated magnetic field strong enough to carve out a protective magnetosphere within Jupiter's deadly radiation environment. Ganymede's magnetic field was a complete surprise to planetary scientists. Moons weren't supposed to generate their own magnetic fields. They were too small and cool to maintain the molten, convecting cores that power planetary magnetism. Yet Voyager's instruments clearly detected magnetic signatures, indicating that Ganymede was somehow generating its own magnetic bubble, creating a safe harbor within Jupiter's particle storm. The discovery revolutionized understanding of how magnetic fields form and persist in small planetary bodies. Ganymede's magnetic field suggested that the Moon had a partially molten iron core, similar to Earth but on a much smaller scale. Tidal heating from Jupiter's gravity was apparently generating enough energy to keep part of Ganymede's core liquid, allowing electric currents to flow and create magnetic fields through dynamo action. This magnetic shield had profound implications for Ganymede's habitability potential. While Europa and Io were constantly bombarded by Jupiter's intense radiation, Ganymede's magnetosphere deflected most of the high-energy particles away from its surface. The magnetic field created a relatively protected environment where complex chemistry could occur without being immediately destroyed by radiation. Temperature and particle measurements revealed that Ganymede's magnetosphere was surprisingly effective at excluding Jovian radiation. The magnetic field strength was only about 1% of Earth's, but it was strong enough to create distinct regions where solar wind particles from Jupiter were excluded or redirected. This created a miniature version of Earth's protective magnetic environment around a moon that was only slightly larger than Mercury. The magnetic field also suggested that Ganymede had a much more complex internal structure than previously thought. Instead of being a simple ball of ice and rock, the Moon appeared to have differentiated into distinct layers: an iron core, rocky mantle, and multiple ice layers, similar to the internal structure of terrestrial planets. This level of differentiation required significant heating and geological activity early in Ganymede's history. Voyager's magnetometer detected variations in Ganymede's magnetic field that indicated the field was not perfectly stable. The magnetic poles appeared to wander slightly, and the field strength varied depending on Ganymede's position in its orbit around Jupiter. These variations suggested that the Moon's magnetic dynamo was influenced by tidal forces from Jupiter, creating a complex interaction between orbital mechanics and internal geology. The presence of a magnetic field also affected Ganymede's thin atmosphere in unexpected ways. Charged particles trapped in the Moon's magnetosphere created auroras at Ganymede's poles, similar to the northern and southern lights on Earth, but much fainter due to the thin atmosphere. These alien auroras were visible only in ultraviolet light and represented the first auroras ever detected around a moon. Scientists realized that magnetic fields might be more common among large moons than previously thought. If Ganymede could generate its own magnetic field, other large moons throughout the solar system might possess similar capabilities. This opened up new possibilities for finding magnetically protected environments where life might persist despite harsh radiation conditions around giant planets. The discovery of Ganymede's magnetic field demonstrated that small worlds could be far more geologically active and complex than their size would suggest. It showed that the traditional view of moons as simple, inactive bodies was fundamentally wrong. They could be dynamic worlds with their own protective systems and complex internal processes. But while Ganymede generated its own magnetic protection, another of Uranus's moons revealed a surface so violently disrupted it looked like the aftermath of a cosmic catastrophe. When Voyager 2 flew past Uranus's small moon Miranda in January 1986, it revealed one of the most bizarre and chaotic landscapes ever discovered in the solar system. This tiny world, only 300 miles across, looked like it had been smashed to pieces and then carelessly reassembled by cosmic forces beyond imagination. The surface showed a nightmarish patchwork of different terrains that seemed to defy every principle of planetary geology. Miranda's surface was divided into distinct regions that looked like they belonged on completely different worlds. Smooth, relatively young plains sat next to ancient, heavily cratered terrain. Enormous grooved regions called coronae showed parallel ridges and valleys that stretched for hundreds of miles, while massive cliffs towered over landscapes that appeared to have been turned inside out. The moon looked like a cosmic jigsaw puzzle where none of the pieces quite fit together. The most spectacular feature was Verona Rupes, a cliff that plunged 12 miles straight down, the tallest known cliff face in the entire solar system. To put this in perspective, if you could somehow fall off this cliff, it would take you over 10 minutes to hit the bottom due to Miranda's weak gravity. The cliff was so tall that a person jumping from the top would have time to take a short nap before reaching the bottom. Scientists struggled to explain how such diverse terrain could exist on such a small world. Miranda was too tiny to have retained significant internal heat from its formation, yet the surface showed clear evidence of recent geological activity. The grooved terrain looked like it had been stretched and twisted by powerful forces, while the smooth plains suggested that some kind of resurfacing process had erased older features. One theory suggested that Miranda had been literally shattered by a massive impact sometime in the distant past, breaking the moon into multiple pieces that later reassembled under their own gravity. This catastrophic breakup and reformation could explain the chaotic mixture of terrain types. Different pieces of the original moon had been jumbled together when gravity pulled the fragments back into a spherical shape. But tidal heating from Uranus provided a more plausible explanation for Miranda's geological chaos. Despite its small size, Miranda orbited relatively close to Uranus and was locked in orbital resonances with other moons that amplified tidal forces. These gravitational effects could have generated enough heat to drive geological activity, creating the grooved terrain and smooth plains through a process similar to what powers volcanoes on Io. The grooved regions showed evidence of extensional tectonics, where the surface had been stretched and pulled apart to create parallel ridges and valleys. This type of terrain indicated that Miranda's crust had been under tension, possibly due to tidal bulges created by Uranus's gravity. The moon was essentially being kneaded like cosmic bread dough, causing its surface to crack and reshape itself over geological time. Temperature measurements revealed that Miranda was one of the coldest worlds ever visited by a spacecraft, with surface temperatures around -300 degrees Fahrenheit. At these frigid temperatures, water ice behaved like solid rock, allowing it to form the massive cliffs and grooved terrain that dominated the landscape. The extreme cold also meant that any geological processes had to be driven by internal heat sources rather than solar warming. The diverse terrain types suggested that Miranda had experienced multiple episodes of geological activity separated by long periods of dormancy. Different regions of the moon appear to have been active at different times, creating the patchwork appearance that made Miranda look like a geological museum displaying samples from throughout its history. Miranda's chaotic surface demonstrated that even the smallest worlds in the solar system could experience complex geological evolution. The moon proved that size wasn't everything when it came to planetary geology. The right combination of orbital dynamics and tidal heating could drive dramatic surface changes even on worlds too small to generate their own heat, through radioactive decay. But while Miranda's surface told a story of chaos and disruption, Saturn's ring system revealed how gravitational forces could create order and precision on an even grander scale. As Voyager 1 approached Saturn's magnificent ring system, scientists expected to find a relatively simple structure, the bands of particles orbiting the planet in neat, orderly rings separated by empty gaps. Instead, they discovered one of the most complex and dynamic systems in the solar system, where tiny moons acted like cosmic shepherds controlling the behavior of trillions of ring particles through their gravitational influence. The most dramatic example was discovered in Saturn's narrow F-ring, where two small moons named Prometheus and Pandora orbited on either side of the ring like cosmic border collies, herding a flock of ice particles. These shepherd moons used their gravity to confine ring particles to a narrow band, preventing them from spreading out or drifting away from Saturn. Without these gravitational shepherds, the F-ring would have dispersed into space long ago. Prometheus and Pandora created a gravitational dance that kept the F-ring particles in line, through a complex process of orbital resonances. When ring particles drifted too close to the inner shepherd moon Prometheus, they were gravitationally accelerated, which raised their orbits and pushed them back toward the center of the ring. Particles that wandered too far outward encountered Pandora, which slowed them down and lowered their orbits back into the ring. But this gravitational herding wasn't a gentle process. Voyager's images revealed that the F-ring was constantly being disturbed by the shepherd moons, creating kinks, braids, and clumps that changed dramatically over just a few hours. The ring looked like cosmic spaghetti being twisted and braided by invisible hands, with some sections appearing to be woven together like rope, while others showed dramatic kinks and knots. The shepherd moons weren't the only gravitational sculptors at work in Saturn's rings. Voyager discovered that many of the gaps between ring sections were maintained by small moons embedded within the ring system itself. These embedded moonlets swept up ring particles in their immediate vicinity, creating gaps and maintaining sharp edges between different ring sections through gravitational clearing. One of the most spectacular examples was the Encke Gap, a narrow division in Saturn's ring that was maintained by a small moon called Pan. This tiny shepherd, only about 20 miles across, orbited within the gap and used its gravity to keep the gap clear of ring particles. Pan's gravitational influence created spiral density waves that propagated through the surrounding ring material like cosmic ripples. The ring particles themselves weren't passive victims of gravitational herding. They actively responded to the shepherd moons through complex resonance effects. When ring particles completed exact fractions of an orbit for every orbit of a shepherd moon, they experienced regular gravitational tugs that could either confine them to specific regions or eject them from the ring system entirely. These resonances created intricate patterns throughout Saturn's rings. Scientists realized they were watching a cosmic ballet where gravity choreographed the movements of countless particles through the influence of small moons. The shepherd moons and ring particles were locked in gravitational relationships that had been stable for millions of years, creating one of the most precisely organized structures in the solar system. Each particle knew its place in this cosmic dance, guided by invisible gravitational forces. Temperature measurements revealed that the shepherd moons were influencing more than just particle orbits. They were also affecting the thermal properties of the rings. Areas near shepherd moons showed different temperatures than the surrounding ring material, suggesting that gravitational interactions were generating heat through particle collisions and tidal friction. The discovery of shepherd moons revolutionized understanding of how ring systems form and evolve around planets throughout the universe. Scientists realized that planetary rings weren't static structures, but dynamic systems constantly shaped by gravitational interactions with nearby moons. The shepherd moons proved that even tiny objects could exert enormous influence over vast regions of space through the precise application of gravitational force. But beyond the visible structures of rings and moons, Voyager was detecting something even more mysterious, the sounds of space itself singing through the cosmic void. As both Voyager spacecraft traveled through the solar system and beyond, their instruments detected something that challenged the popular notion that space is completely silent. Hidden within the vacuum of space, electromagnetic waves were singing songs that no human ear could hear. Plasma waves that created a cosmic symphony of radio emissions, spanning the entire electromagnetic spectrum. These weren't sound waves that could travel through air like music on Earth. Instead, they were electromagnetic oscillations in the thin plasma that fills the space between planets, creating radio frequencies that Voyager's instruments could detect and convert into audio signals. When scientists played back these recordings, they heard the eerie voices of planets, moons, and magnetic fields calling out across the cosmic darkness. Jupiter's magnetosphere produced some of the most dramatic plasma wave emissions, generating radio signals so powerful they could be detected by simple shortwave radios on Earth. As Voyager passed through Jupiter's magnetic field, the spacecraft recorded whistling sounds created by lightning in the planet's atmosphere, along with strange chorus effects generated by electrons spiraling through the magnetic field lines. Jupiter was broadcasting its own radio station across the solar system, Saturn's plasma waves told a different story. They revealed the complex interactions between the planet's rings and its magnetosphere. As charged particles from Saturn's magnetic field collided with ring particles, they created electromagnetic disturbances that propagated through space like cosmic thunder. Voyager detected these collisions as crackling static punctuated by mysterious musical tones that seemed to come from the rings themselves. The most haunting sounds came from the space between planets, where the solar wind created its own electromagnetic symphony. As the stream of charged particles from the Sun encountered magnetic obstacles like planetary magnetospheres or interplanetary magnetic field boundaries, it generated bow-shock waves that produced distinctive whistling and whooshing sounds. These were the sounds of the solar wind itself, singing as it flowed past obstacles in its path. Voyager's plasma wave instrument could detect frequencies ranging from 10 Hz to 56 kHz, covering the range of human hearing when converted to audio. Scientists discovered that different types of plasma waves had characteristic signatures. Electron cyclotron waves sounded like bird songs, while ion acoustic waves resembled ocean surf. Each region of space had its own acoustic fingerprint, created by the local plasma environment. The most significant plasma wave discovery came when Voyager 1 crossed the heliopause and entered interstellar space. The spacecraft detected a dramatic change in the background plasma wave environment, like stepping from a noisy room into a quiet library. The chaotic radio emissions from solar wind turbulence were replaced by the more organized plasma waves of the interstellar medium, marking humanity's first direct detection of sounds from beyond our solar system. Scientists realized that plasma waves weren't just acoustic curiosities. They were powerful diagnostic tools for understanding space environments. The frequency, amplitude, and propagation characteristics of these waves revealed information about plasma density, temperature, and magnetic field strength that couldn't be obtained any other way. Voyager was essentially using space as a giant musical instrument to probe the physics of planetary magnetospheres. The plasma wave emissions also revealed dynamic processes that were invisible to optical cameras. Voyager detected plasma waves generated by particle precipitation into planetary atmospheres, creating the electromagnetic signatures of auroras on worlds too far away to photograph directly. The spacecraft could hear auroras on planets where it couldn't see them, extending its sensory capabilities beyond the limitations of visible light. Some of the most mysterious plasma waves came from interactions between planetary moons and their parent planets' magnetic fields. As moons like Io and Europa moved through Jupiter's magnetosphere, they generated electrical currents that produced distinctive radio emissions. These electromagnetic interactions created a form of magnetic coupling between moons and planets that was previously unknown. As both Voyagers continued their journeys, they carried with them an ever-growing library of cosmic sounds that revealed the hidden electromagnetic activity throughout the solar system and beyond. But these plasma waves were just one aspect of the complex boundary regions that Voyager discovered as the solar wind encountered obstacles throughout its journey. Throughout their 45-year journey, both Voyager spacecraft served as cosmic surveyors, mapping invisible boundaries created by the solar wind as it flowed outward from the Sun and encountered various obstacles in its path. These boundary regions weren't marked by visible features. They were defined by sudden changes in magnetic fields, particle densities, and plasma wave activity that revealed the hidden architecture of our solar system. The first major boundary each Voyager encountered was the bow shock ahead of Jupiter's magnetosphere. Here, the solar wind, traveling at over 1 million miles per hour, slammed into Jupiter's magnetic field and was forced to slow down and change direction. This created a standing shockwave in space, similar to the sonic boom created by a supersonic aircraft, but formed by charged particles instead of sound waves. At each giant planet, Voyager discovered that the solar wind carved out distinct regions with their own characteristic properties. The magnetosheath, the turbulent region between the bow shock and the magnetosphere, was filled with heated and compressed solar wind particles that had been processed by their passage through the shock. Inside each planet's magnetosphere, the solar wind was completely excluded, creating protected cavities where planetary magnetic fields dominated. These boundary regions weren't static walls. They breathed and flexed as solar wind conditions changed. When the sun released particularly strong bursts of particles during solar storms, planetary magnetospheres compressed like cosmic balloons being squeezed. During quiet periods, they expanded outward, pushing their boundaries farther into space. Voyager witnessed these dynamic changes in real time as magnetic field readings fluctuated wildly. Saturn's magnetosphere proved to be particularly responsive to solar wind variations because its magnetic field was weaker than Jupiter's. Voyager detected occasions when Saturn's magnetosphere was so compressed by strong solar wind pressure that some of the planet's moons were temporarily exposed to direct solar wind bombardment. The boundary between Saturn's protected magnetosphere and interplanetary space could shift by hundreds of thousands of miles within hours. But the most significant boundary discovery came when Voyager 1 detected the termination shock in December 2004, since the region where the solar wind itself finally encountered enough resistance from interstellar space slow down from supersonic to subsonic speeds. This boundary marked the beginning of the heliosheath, a turbulent region where solar wind particles were slowed, heated, and compressed as they prepared for their final confrontation with interstellar space. The termination shock wasn't a simple, well-defined boundary like planetary bow shocks. Instead, it was a complex, multi-layered region where the solar wind underwent a gradual transition from high-speed flow to slow, turbulent motion. Voyager 1 crossed this boundary multiple times, as shock waves and instabilities caused it to move back and forth across the spacecraft's trajectory, creating a cosmic ping-pong effect. Temperature measurements revealed that crossing these boundaries involved dramatic changes in particle energy. Solar wind particles were heated to millions of degrees as they passed through shock waves, while magnetic field compressions created regions where particle densities increased by factors of 10 or more. These boundary regions were cosmic particle accelerators, where gentle solar wind was transformed into high-energy plasma. The boundaries also acted as cosmic filters, allowing some types of particles to pass while blocking others. Planetary magnetospheres excluded most solar wind particles but allowed cosmic rays from deep space to penetrate. The heliosphere excluded most interstellar particles but allowed solar wind to flow freely outward. Each boundary represented a different balance between competing forces in the cosmic environment. Scientists realized that similar boundary regions probably existed around every star in the galaxy, creating a complex network of invisible structures that channeled the flow of charged particles through interstellar space. Understanding these solar system boundaries provided insights into how stellar winds interact throughout the Milky Way galaxy, revealing fundamental processes that shape the cosmic environment around all stars. As Voyager 1 finally crossed the heliopause and entered interstellar space, it had mapped the complete architecture of our solar system's boundary regions, from planetary magnetospheres to the edge of the sun's influence itself. But the mapping of these invisible boundaries was made possible by one of Voyager's most revolutionary discoveries: magnetic field measurements that challenged every theory about how planetary magnetic fields behave. When both Voyager spacecraft began their grand tour of the outer planets, scientists thought they understood how planetary magnetic fields worked. Earth's magnetic field provided the template, a relatively simple dipole field aligned with the planet's rotation axis and generated by electric currents in the molten iron core. But Voyager's magnetic field measurements from Jupiter, Saturn, Uranus, and Neptune shattered these assumptions and forced a complete rewrite of planetary magnetism theories. Jupiter's magnetic field was the first shock. Instead of being roughly aligned with the planet's rotation like Earth's field, Jupiter's magnetic axis was tilted 11 degrees off-center and significantly more complex than any theoretical models predicted. The field strength was 20,000 times more powerful than Earth's, creating a magnetosphere so large it could easily contain the Sun. If visible to the naked eye, Jupiter's magnetosphere would appear larger than the full moon when viewed from Earth. But Jupiter's magnetic complexity was nothing compared to the revelations that awaited at Uranus and Neptune. Both ice giant planets had magnetic fields tilted at impossible angles of 59 degrees for Uranus and 47 degrees for Neptune. These weren't minor measurement errors. They represented fundamental differences in how magnetic fields could be generated inside planets. The traditional model of magnetic fields originating in planetary cores clearly didn't apply to these worlds. Even more puzzling was the discovery that both Uranus and Neptune had magnetic fields that didn't even pass through their centers. The magnetic dipoles were offset by significant fractions of each planet's radius, as if invisible bar magnets had been shoved partway inside each world and left floating off-center. This configuration violated every principle scientists thought they understood about planetary magnetism. Saturn provided yet another magnetic mystery. Its magnetic field was almost perfectly aligned with the planet's rotation axis, so perfectly aligned that it seemed physically impossible. Theoretical models suggested that no planetary magnetic field could be that precisely organized without some external mechanism maintaining the alignment. Saturn's magnetic field was too perfect to be natural, yet it clearly existed. The magnetic field measurements also revealed dynamic processes that had never been observed before. Jupiter's magnetic field was constantly fluctuating as the planet's rapid rotation dragged charged particles around in complex patterns. The magnetosphere rotated with the planet every 10 hours, creating a cosmic magnetic lighthouse that swept charged particle beams across space like rotating searchlights. Voyager discovered that planetary magnetic fields weren't isolated phenomena. They were intimately connected to their host planets' moons and ring systems. Io's volcanic eruptions fed material into Jupiter's magnetosphere, creating a donut-shaped cloud of charged particles that modified the entire magnetic environment. Saturn's rings interacted with the planet's magnetic field to create spokes and other mysterious features that couldn't be explained by gravitational forces alone. The spacecraft also revealed that magnetic fields could be generated in unexpected places. Ganymede's small magnetic field proved that moons could create their own magnetospheres within their parent planet's magnetic environments. Even some asteroids and comets showed evidence of weak magnetic fields, suggesting that magnetism was far more common in the solar system than previously thought. Temperature and particle measurements showed that planetary magnetic fields were powerful shapers of space environments. They trapped charged particles in radiation belts, accelerated particles to incredible energies, and created complex electrical circuits that linked planets to their moons through invisible magnetic field lines. Magnetic fields weren't just passive phenomena, they were active players in planetary system dynamics. The magnetic field discoveries forced scientists to develop entirely new theories about how planetary magnetism works. Instead of simple dipole fields generated in cores, planets appeared to have complex magnetic dynamos operating at different depths and with different orientations. The magnetic field generation process was clearly much more complicated than anyone had imagined. These revelations about planetary magnetism had implications far beyond our solar system. If the magnetic fields around the planets in our cosmic neighborhood were so varied and complex, then the magnetic environments around extrasolar planets might be equally diverse. Understanding planetary magnetism became crucial for assessing the habitability of worlds around other stars. But while magnetic fields revealed the invisible architecture of planetary systems, Voyager's temperature measurements were documenting some of the most extreme thermal environments in the known universe. Throughout their journey across the solar system, both Voyager spacecraft carried infrared instruments that measured temperatures across a range of environments more extreme than anywhere found on Earth. From the volcanic furnaces of Io to the cosmic deep freeze of interstellar space, these temperature readings revealed a universe where matter existed under conditions that challenged the very definition of hot and cold. Io provided the most dramatic temperature extremes in the solar system. Voyager's infrared detector measured volcanic hotspots reaching 3,000 degrees Fahrenheit, temperatures hot enough to melt copper instantly and rival the heat found in steel foundries. These weren't gentle lava flows like those found in Hawaii. They were explosive eruptions that launched molten sulfur hundreds of miles into space at temperatures that would vaporize most metals. But just miles away from these volcanic furnaces, Io's surface temperatures plunged to minus 260 degrees Fahrenheit, creating one of the most extreme temperature gradients ever measured on any world. The volcanic regions were literally red-hot islands of molten rock, surrounded by landscapes cold enough to freeze carbon dioxide solid. Stepping from a volcanic plain to a cold region on Io would be like walking from the inside of a blast furnace directly into liquid nitrogen. Europa presented a different kind of thermal mystery. Despite being farther from the sun than Io, Europa's subsurface ocean remained liquid at temperatures around minus 100 degrees Fahrenheit, still cold enough to kill any Earth life instantly, but warm enough to maintain the largest body of liquid water in the solar system outside of Earth. Tidal heating from Jupiter generated just enough energy to keep this vast ocean from freezing solid. Saturn's moon Titan showed how atmospheric greenhouse effects could warm a world far from the sun. Despite receiving only 1% of the sunlight that Earth enjoys, Titan's thick atmosphere trapped enough heat to maintain surface temperatures around minus 290 degrees Fahrenheit. While still brutally cold by Earth standards, this was actually warm enough for liquid methane to exist, creating hydrocarbon lakes and weather systems impossible anywhere else in the solar system. The outer planets themselves revealed temperature extremes that defied easy explanation. Neptune, despite being 30 times farther from the sun than Earth, had atmospheric temperatures that were almost identical to those found on Uranus, which was much closer to our star. Neptune's internal heat source was so powerful that distance from the sun became almost irrelevant to its atmospheric temperature. Voyager's temperature measurements of planetary ring systems revealed another thermal puzzle. Saturn's rings showed complex temperature variations that had nothing to do with solar heating. Some regions of the rings were warmer than others due to particle collisions and electromagnetic heating, creating thermal patterns that constantly shifted as the rings evolved. The rings were essentially cosmic heat engines powered by gravitational and electromagnetic forces. The most extreme cold measurements came as Voyager 1 entered interstellar space. The cosmic background temperature in the void between stars measured just 4 degrees above absolute zero, negative 455 degrees Fahrenheit. At these temperatures, almost all matter except hydrogen and helium would be frozen solid. This was the thermal environment that dominated most of the universe, where the absence of nearby stars created conditions of almost perfect cold. But even in interstellar space, Voyager detected unexpected temperature variations. Shockwaves from ancient supernova explosions had heated some regions of interstellar gas to millions of degrees, creating bubbles of incredibly hot plasma floating in the cosmic deep freeze. These hot regions were so tenuous that a thermometer would still read near absolute zero, but individual gas atoms were moving at speeds equivalent to millions of degrees of temperature. The spacecraft also measured the thermal effects of magnetic fields throughout the solar system. Charged particles trapped in planetary magnetospheres were heated to temperatures of millions of degrees through magnetic acceleration and compression. Jupiter's radiation belts contained particles with effective temperatures higher than the surface of the Sun, even though the overall environment was still the cold vacuum of space. These temperature measurements revealed that the universe was filled with thermal extremes that made Earth's climate seem remarkably mild and stable. The range of temperatures found just within our own solar system spanned more than 3,000 degrees, from volcanic hotspots to the cosmic background temperature, creating environments where matter existed in states impossible to reproduce in terrestrial laboratories. As Voyager continued collecting these extreme temperature readings, they provided crucial data for understanding how energy flows through planetary systems and how life might adapt to thermal environments completely different from Earth's temperate conditions. 45 years after leaving Earth, both Voyager spacecraft continue racing through the cosmic darkness, their nuclear hearts still beating steadily as they transmit humanity's first reports from interstellar space. These two small machines have fundamentally transformed our understanding of the solar system and our place within the vast universe that surrounds us. The discoveries made during Voyager's grand tour reads like science fiction that became reality. active volcanoes on alien moons, global oceans hidden beneath ice, hexagonal storms larger than Earth, twisted magnetic fields, and ring systems that sing with electromagnetic music. Each world visited revealed surprises that forced scientists to rewrite textbooks and expand the boundaries of what seemed possible in planetary science. Perhaps the most profound discovery was that our solar system is far more dynamic and alive than anyone had imagined. Instead of finding dead worlds orbiting in eternal silence, Voyager revealed a cosmic ecosystem where moons erupt with geysers, atmospheres circulate with supersonic winds, and magnetic fields create invisible highways for charged particles. The outer planets proved to be entirely different kinds of worlds, operating by their own physical laws. The journey demonstrated humanity's remarkable ability to extend its senses across impossible distances through robotic exploration. Voyager's instruments became our eyes and ears in the cosmic wilderness, allowing us to see storms on Neptune, hear radio waves from Jupiter, and witness the birth of new worlds. These machines became extensions of human consciousness, reaching into the previously unknowable darkness. Each spacecraft carries the golden record, humanity's message to any alien intelligence that might find these cosmic bottles cast into the interstellar ocean. Long after Earth has forgotten these missions, Voyager 1 and 2 will continue sailing between the stars as ambassadors from our small planet, carrying greetings, music, and images that capture the essence of human civilization. The data streaming back from both spacecraft continues to revolutionize our understanding of the boundary between our solar system and interstellar space. These measurements help scientists understand how our sun interacts with the galaxy around it, revealing processes that occur around every star in the Milky Way. As both spacecraft gradually lose power and their instruments fall silent one by one, they will join the small but growing fleet of human artifacts traveling between the stars. Future civilizations may find them drifting in the galactic wilderness millions of years from now, carrying evidence that intelligence once arose on a blue world orbiting an ordinary star. The Voyager missions proved that the most important discoveries often come from the courage to venture into the unknown with open minds and carefully calibrated instruments. By pointing our cameras and sensors toward the darkness beyond familiar worlds, we discovered that the universe is stranger, more beautiful, and more dynamic than our wildest dreams had suggested. Both Voyagers continue their eternal journey, racing away from the sun at speeds that will carry them past nearby stars in tens of thousands of years. They represent humanity's first successful attempt to touch the infinite, transforming us from prisoners of a single world into explorers of the cosmic ocean. The journey that began in 1977 has become a voyage that will outlast human civilization itself, carrying our message and our dreams into the star-filled darkness that waits beyond the edge of everything we call home.